Hello. Today we're going to look at how to solve equations when you have square roots on both sides of the equation. Let's go. Okay, so here's our first equation. The square root of 3x minus 8 plus 1, and that plus 1's on the outside of the square root, equals x plus 5. Okay, to get rid of these square roots so that we can combine like terms with x's, we have to do the opposite of square rooting, which is we have to square. So if I square this entire thing, okay, on this side, the square root of x plus 5 squared, that just gets me x plus 5. When I square something under a square root, I release the square root. Now, over here, I have a binomial, and so I have to FOIL. So I can't just square this term and square that term, right? You have to write out square root of 3x minus 8 plus 1 times square root of 3x minus 8 plus 1, and then you have to FOIL. If that's unfamiliar to you, go check out this video. Otherwise, first term, this root times this root, just like over here, that's that squared. That just gets us 3x minus 8. Outsides, this times 1 gets us a square root of 3x minus 8. Insides, 1 times same thing. That gets us a second one. So I'm just going to write this as 2 of them. And then last term's 1 times 1. And that, of course, equals x plus 5. So I'm going to combine my like terms. Minus 8 plus 1, that's minus 7. And I write that up here. And now I'm going to get everything away from this square root because I'm going to need to square again because I still have this middle term here. And that's because of this plus 1. If the problem had just said square root of 3x minus 8 equals square root of x plus 5, much simpler. Square both sides, the square roots go away. But because of this plus 1, we got to do this extra step. So I add 7 to both sides. I subtract 3x from both sides. And now before I square both sides, I'll go ahead and divide away. And now I square both sides again. So when I square this side, I just get 3x minus 8. When I square this side, I get x squared minus 12x plus 36. Now, again, I'm going to bring everything over to this side. And I've got x squared minus 15x plus 44 equals 0. You can go ahead and factor this using any method you like. I see 44 doesn't have a lot of options. 4 and 11, that gets me a 15. Both of them negative, and multiply them together gets me the positive. And so my two possible answers are 4 or 11. Now, notice I say possible because whenever you find yourself squaring both sides as part of your process, you may create what's called an extraneous solution. So we're going to try each of these and see if either is extraneous. When I put 4 back into my original equation, I get 3 times 4, that's 12, minus 8, that's 4, square root of that is 2, plus 1, that's 3. When I do 4 plus 5, that's 9. Square root of that is 3. 4 checks out. When I try 11, I get 33 minus 8, which is 25. Square root of 25 is 5. Plus 1, that's 6. 11 plus 5, that's 16. Square root of 16 is 4. 11 does not work. 4 is my only solution. Okay, let's do one more. Okay, this time I have the cube root of something, 8x to the third minus 1 equals 2x minus 1. And so again, how do I get rid of this? I have to cube both sides. So when I cube a cube root, I just get what's under the cube root. When I cube this, okay, this is 2x minus 1 times 2x minus 1 times 2x minus 1. I can go ahead and remember my binomial theorem and Pascal's triangle. If those are not familiar to you, then go ahead and take a look at these videos. Otherwise, I'm going to remember that for my cubed, my initial coefficients are 1, 3, 3, and 1. That my first one has this cubed and this one to the 0 or just 1, and then plus this squared, and this to the 1, and then this to the 1 and this squared, and finally this cubed. Again, if that's not familiar to you, go check out those videos. Otherwise, let's do that math out. We get 8x cubed minus 12x squared plus 6x minus 1. Now I'm going to move everything to one side. I'm going to subtract 8x cubed from both sides. I'm going to add 1 to both sides. And I get 0 is negative 12x squared plus 6x. I'm going to factor a negative 6x out of both terms. And so my two possible answers are 0 and 1/2. And then I would go ahead and try both of those out and make sure that I don't have an extraneous solution. When I put 0 in here, I get the cube root of negative 1 or negative 1. When I put 0 in here, I get negative 1. That checks. When I do 1/2, I get 8 times 1/8. So that's 1 minus 1, that's 0. Or I get 2 times 1/2, that's 1 minus 1, that's 0. Both of these solutions work. So that's two examples of how to work when you have roots on both sides of the equation. Check out some of these other videos. Leave any problems that you're struggling with in the comments and let me make a video to help you out. Consider subscribing to my channel so that you know when I put out a new video. And as always, keep on mathing.